Good afternoon and welcome to our presentation, Pressing Wheel Bearings Replacing Gen 1 or Cartridge-Style Wheel Bearings. My name is Andrew Markell. I'm the Director of the Content for Babcock's Media. I'm the moderator and presenter for today's event. Today's event is sponsored by BCA Wheel Bearings and Wheel Bearings. So we're going to get started here. With us from BCA, we've got two of their top technical guys. With me right now is Matt Gorski. He started out as an automotive technician for 12 years, and he is now NTN's Manager of Product Development. And he manages some product lines for NTN and BCA. Also with us is Mark Tarrant. He is the engineering guy and application guy. He's going to be able to answer a lot of the application-specific questions that you might have. So let's get started. The goals at the end of this, well, we're going to make you more comfortable handling these wheel bearing jobs. And we're going to make you more aware of the products and tools that are out there that can help you be more productive. We're also going to understand some of the more theoretical things, like preload, also air gap for the ABS sensor and the encoder ring. And overall, we're going to be able to give you an idea when you start on one of these jobs, what needs to be addressed, and some of the pitfalls that you could run into. As always, we're going to be answering those questions live, so please tap them in as soon as possible. So I know your first question, what is a Gen 1 wheel bearing? Well, the old guys call this a cartridge-style wheel bearing. It presses into the knuckle, and the preload is set by you, the technician. And this is done with the flange and also part of the axle. A lot of these bearings on modern vehicles, well, they actually have the encoder ring or tone ring for the ABS system. And it's critical with that tone ring that you get the air gap set properly. And it's probably one of the most fragile items on the wheel bearing itself, and you need to take extra care when you're installing one of these. Okay, this is sort of the worst offenders to really look at when you're installing wheel bearings. 1.4 hours for a Ford Focus. VW Jetta, 2 hours. And these are Mitchell labor times. Ford Transit, a little bit more. Toyota Camry, Jaguar X-Type, which I know because I actually used to own one of those. And also a Honda Civic. So you're looking at least 1.5 hours or 1.4 hours to do this job. And if you make a mistake, it's just going to get even longer, and you're going to be working on your own time, more or less for free, if there is an error in the installation. Hey, Mark, can you think of any other vehicles on that list that are the worst, or basically the ones you see the most returns on?
Honestly, I probably see Ford Escape the most. Between the Focus and the Escape, I probably see the most. But it's also worth noticing is a lot of these parts, I get them back and somebody's complaining about there being an ABS issue. Well, you can tell once you examine the part that the part was initially installed incorrectly, so it was installed backwards, and then they tried to repress it on, and then they had issues. But so it's kind of funny. Like the two I see the most are the Focus and the Escape. But of those, vast majority of the parts I see, there's actually nothing wrong with them. The part was actually installed wrong to begin with.
Huh. And when they install it on the vehicle, they just get the ABS systems not working properly.
Correct, yeah, because the ABS can't function because it's not picking up any signal because the encoder is facing the wrong direction.
Oh. And this sort of brings up some of the symptoms that you'll see on a lot of these vehicles. I mean, the first sign I typically see with a wheel bearing failure is noise. Play sometimes occurs. You can actually feel it. I mean, it's really difficult on some of these bearings. I mean, a bearing could be making the most horrible noises, but it probably won't have too much play in it. But what I'm finding out more and more is that the ABS light is on, and it's deactivated the ABS, stability control, and even the cruise control on some vehicles. And this is why the customer might bring the vehicle to your shop. And this is all due to the encoder ring and changes to the air gap between the sensor and the encoder ring. So this is sort of steps I like to perform before I really start digging into the job and I start pulling out the black oxide tools to pull the flange off and also pull the bearing out, is look at the code first of all. If you're seeing a code for a short, an open, or other issues with the electrical side of the ABS sensor, investigate that problem further before moving on to the wheel bearing replacement. If it's for erratic performance or the generic wheel bearing malfunction or wheel speed sensor malfunction for that corner of the vehicle, chances are that's the issue is with the wheel bearing. But make sure you're doing a full diagnostic before you start taking things apart. Most of all, look at the service information before you start. Even though you've probably done a lot of these, if it's a brand new vehicle, chances are you'll avoid making a mistake by looking at the service information and also the TSBs. But you could find out in there that there is a step that makes it a lot easier to perform the job. It could be a certain way how you move the control arm, pull a certain bolt, so you don't have to deal with, let's say, like a ball joint and possibly damaging the boot by trying to get that knuckle out. Another thing, make sure you're pulling that sensor out to make sure it comes out of the knuckle. This is in a high corrosion area, and typically rust will get in between the sensor and the hole in the knuckle itself and pretty much wedge that wheel speed sensor head in there. And if you're starting the job and you know that you need a brand new one, well, this is the time to order it, so hopefully your parts supplier can get one out to you. So by the time you're putting on the flange and putting on the brakes, well, hopefully it'll be there and you can finish the job. The flange, we're going to talk about the flange a lot in this presentation because it's probably one of the most misunderstood and also the most difficult parts to press into the final assembly. But before you start taking things apart, it's critical that you measure runout. Measure runout in the rotor and then also measure runout in the flange itself. If you're seeing anything more than 5 thousandths worth of runout in the flange, chances are it's due for a brand new flange. Just from distortion, a pothole that can occur, because 5 thousandths worth of runout, that's about the maximum you can probably correct with an on-the-car brake lathe before you start really compromising a rotor thermally. Another tip, and this comes from a lot of OEMs, make sure that you are indexing the rotor to the flange, even if there's no problem with runout. This way, you're not stacking the tolerances against you. So let's say you take that rotor off and you move it 180 degrees. Well, you could have 3 thousandths worth of runout all of a sudden to where the previous assembly only had maybe 1 thousandths. So make sure you're indexing it with a grease pen or piece of chalk to make sure that you put the rotor back on the same way. And another thing to remember is there are flanges available, either through traditional aftermarket sources or in some cases the dealer. Most of all, look for corrosion. Some corrosion is normal, but if it's excessive, well, you may want to pay attention to that entire corner of the vehicle. One thing that's always tripped me up on certain jobs, it's the condition of the studs on the flange itself. Either they're cross-threaded, damaged, the nut's difficult to get off, and unfortunately the thing we've probably seen over the past 5 years are the swollen lug nuts on the vehicles to where you get that corrosion between the chrome cap and the lug itself. You can't even start the job if those are in bad shape. But Matt sort of shared a tip with me that before you take things apart is to make a certain measurement of the flange. And Matt, could you elaborate on that?
Sure. When you're taking the flange out of the bearing assembly, it's always a good idea to get the gap kind of measured between the inner ring of the wheel bearing and the flange itself, so that when you're reinstalling the flange into the bearing assembly, it maintains the same distance away, so that when you put the rotor on and the calipers, everything lines back up in the original position, because sometimes, you can press it in too far or not far enough, and that's going to affect the offset of how the rotor sits in the caliper assembly.
It's good to know that before you encounter problems when you're doing the final assembly and the preload of the bearing.
A lot of times you can tell by the corrosion once you press it off where it stopped and where it was exposed to the air, and sometimes you can't. So as you do more and more, you're going to become more and more experienced and feel more comfortable doing it. But for some of the people that are just starting in the industry, it might be a good idea to just take some measurements to make sure that when it goes all back together, it's in the same configuration as before it came apart.
So let's talk about the axle nut. This is probably one of the most misunderstood components on a vehicle, and I say that a lot. But it's a component that is a one-time use item. Once it's tightened down and it's holding the preload on that bearing, well, the axle nut needs to be replaced every time it's been removed. And also pay attention to how it goes on the vehicle. If it's a cotter pin or if you have to use a punch, pull that out. But the key thing with this is the removal of the nut. Back in the day when we had a lot of steel wheels, you could remove the nut with the vehicle on the ground and you could get to the axle nut itself. If you're dealing with a vehicle with a lot of alloy wheels, it may be impossible to get to that axle nut through the access and the hole. So you maybe wind up putting a screwdriver, which I like to call my expendable screwdriver, in there, or a punch and in the fins of the rotor, and then using that to steady itself against the caliper bracket. But the key here, I don't know how to say this enough, but be conservative with your use of the impact. Use a wrench or socket wrench or breaker bar to loosen the nut. If you're sitting there with a impact just going crazy on the nut itself, well, you're causing a lot of shock and impact to the driveline. And just think about it. You got a car on a lift. You got the suspension drooping down. Another bearing-intensive product, well, it's actually the CV joint and tripod joint or rapise joint on some vehicles. So if you're trying to get that axle nut off and you just got that wailing away, you're going to be causing damage to those components. And those are the needle bearings inside and also the surfaces inside some of those joints. And if you're using it to install an axle nut or any component that has a torque specification, if you're using impact, you have zero control over the final torque. Another thing I've heard, I haven't experienced this myself, is that constant hammering with an impact on an axle nut can actually damage the spider gears inside a differential. Let's talk about removing the flange. A couple options. The slide hammer. It works. Some vehicles you'll have to use a bearing separator, which have the two sides that come down and you pull it out that way. Some of them actually do have some special service procedures that you may need to look at the service information to do it the right way without causing any damage to the flange. So I highly encourage that. Removing the inner race, I didn't get off the bearing on this, but that inner race that's left behind, it's near impossible to get off by hand. And it's designed that way. You can either use a special puller to get that race off. What I typically do is I've used a Dremel tool, cut a slot in it, and then hammer it off with a cold chisel. I typically try not to cut too deep on the flange itself because then I don't want to damage the surfaces, which could affect how the bearing is torqued down. I've seen some guys, they use a die grinder with a large diameter wheel. It can be difficult because you have very little control over the angle of the cut and also causing damage to that race itself, to the flange surfaces. And once you get that off, you probably should be cleaning that up with a emery cloth just to make sure that there's no corrosion or other things that could make it more difficult to install into the new bearing. Let's talk about the axle. You've got the axle out. The things to look on there, well, first of all, look at the threads for the axle. Make sure that they're nice, square, sharp, they're not rolled over. If they are, you need to address that either with a die or a thread chaser, or you may even need a brand new axle in some cases. Look at the shoulders where the axle itself makes contact with the inner race of the bearing. This is the other surface opposite the flange that helps to set the preload on the bearing and the final torque. If there's any issues with distortion, damage, corrosion, it's going to cause issues with setting the torque and the preload for the bearing. Another thing, look at the entire axle. Look at the boot. If it's nearing its life, if there's leaking grease, replace the axle. And another tip, and this actually comes from two TSBs from BMW and also Nissan, they advise putting a light coating of a moly lubricant on the shoulders and a little bit of the splines of the axle itself. This helps to eliminate a clicking noise that can occur. BMW and Nissan were actually experiencing this on some of their newer vehicles that roll off the assembly line. But if you have an axle and there's maybe some issues there with noise, just try a light coating of MonoLoop on those surfaces to eliminate that clicking noise that typically occurs under acceleration. Okay, here comes the fun stuff, pulling out the outer race of the bearing. Make sure you have the correct adapters, no matter if you're working on a press or a forcing screw on the vehicle. These bearings are friction fit, so they're designed to come out. And just remember, if you're using a ton of force, either on a press or with a forcing screw, back up and check your setup to make sure you're touching the right points and you're going in centered to the bearing. Which kind of brings up our next point. This is kind of the great debate, on or off the vehicle. Both either a press in the machine room or next to your bay, and the blow molded case with the bearing puller, like a hub tamer from OTC, they both have their advantages and disadvantages. If you're using the press, well, you have a little bit better control if you have the right fixtures on the press itself. Unfortunately, the knuckle needs to be removed from the vehicle. And it's an extra trip you have to make. And Matt, we were talking about this before in regards to making sure you have the proper fixtures on the hydraulic press to make sure that you're pressing in the new bearing square. What's been your experience with that?
Well, again, as you do more of these styles, you're going to, build up more of a, inventory of different spacers and shims and blocks that you can get the knuckle as, perpendicular to the mount or I-beams on the press as possible. But in some cases, it's extremely frustrating. I haven't seen any true kits or adapter sets specifically for knuckle assemblies to get them square for the installation and removal of the bearing assembly. So the truer you can get it, the easier it's going to be, the less damage you're going to do to the bore of the knuckle, and it's just going to be safer. So if you're uncomfortable, not sure, ask someone in the shop that may have a little bit more experience, and they'll show you how to shim and space that thing up safely so that when you're pressing it out and you're, 8,000 PSI on the hydraulic press and that thing pops loose, stuff just doesn't go flying.
Yeah, my experience has been looking at the service information and the different fixtures an OEM can have to press the bearing in and out. If you had to buy every one for every single vehicle, it would be a very expensive proposition. But they do make some jobs a little bit easier.
Mm-hmm.
So let's talk about on the vehicle. It's either a forcing screw, but recently I did see a hydraulic option for one of these on the vehicle kits, which I thought was great. In some ways, I feel, personally to me, I have less control over the final depth and feel of how far in the bearing goes. I'm always second guessing myself, but that's probably just me. Make sure your setup is not making any contact with the seal or the inner parts of the wheel bearing. If you have any contact with these, you can cause damage to the seals or potentially the encoder ring. Best advice ever given to me is do not use sockets. First of all, they can crack and be damaged. Second of all, a lot of them have rounded edges, and those rounded edges can slip off the outer ring of the bearing and damage the bearing. So just be aware of that, and make sure your setup is true so you're not damaging anything on the brand new wheel bearing. Which kind of brings up our next point. We're going to be talking about the knuckle. If you're having to use a lot of force to get that new bearing, or you had to use a lot of force to get the old bearing out, look for distortion in the knuckle itself. A lot of these knuckles can be damaged just from potholes, accident damage, and it will distort the bore on the knuckle. And it's really hard to detect. You can't do it visually. If it's visually, chances are the vehicle is maybe totaled. But the tool to use is a tapered bore gauge, and this is used to detect taper in engine cylinders and other bores. But you just open it up, and just draw it back and forth lightly to see if there's any pull or distortion or it becomes loose. And if there is, well, you might need to get a new knuckle for the vehicle. Once you get everything out of the knuckle itself, make sure you're cleaning up that bore. Make sure that you're taking care of any corrosion that's inside the bore, any rust, nicks, and you're removing all of that debris that may hold that circlip in that groove. Because if it's filled up with debris or other stuff inside that groove, it's going to be very difficult to get that clip to seat. And another thing with you want to lubricate the bore itself, and this helps with the installation. And Matt, you brought up a really good point the other day about the role of the lubricant, and you kind of outlined what lubricant you're using.
Well, I just know that in the past I've used like an assembly lube. I used to use caliper and wheel cylinder rebuilding lube. Came in a little 2-ounce bottle, but that makes it safe for any of the rubber components or seals on that cartridge style bearing. But yeah, I would just give a little bit of coating on the bearing and in the bore, help install the bearing smoothly, and also once it's installed, when you set the torque on the axle nut, holding the whole assembly together, that will also help, center and set the true bearing preload, because it's able to move a little bit easier. So you just want everything to be able to move fairly smooth. So both for assembly and for setting that axle torque. Because any kind of burrs, anything that's going to hang up that bearing going into the bore is just going to cause multiple problems.
Are there any types of lubricants a technician should stay away from that could possibly damage the rubber or other compounds in the seal itself?
Yeah, there's some lubricants out there that can actually cause the rubber in the seals to swell. Anything with hydrocarbon or oil-based stuff is generally not good. So you want to stick with the synthetics or the silicone or the Teflon-based lubricants, and away from anything that has the natural, type of oils in it.
The petroleum distillates.
Correct.
I guess at this point right now in the bearing job, you're getting ready to press that brand new bearing in. With this, you have to ask that question, what side goes in first? And this goes back to some of the first slides where we were talking about the ABS sensor, because a lot of these bearings have an encoder ring on them, and it can be difficult to identify which side has the encoder ring and which side is just a normal seal that should be facing outwards. Matt and Mark, can you give me an idea of these on some of the vehicles, the appearance, and what are some of the tools that a technician can use to identify that encoder ring?
Well, this is Mark. Well, for starters, it's going to be nearly impossible to identify just by looking at it. The seals, the magnetic encoders embedded in the seal. So what you're seeing on the outside is just the seal, so you don't see the magnetic encoder. What I strongly recommend to people when they're trying to figure out which side is which is use something like a paper clip. That's always a good one. I know in other cases when I've had like a tech call and somebody had an issue, they were using a screwdriver, which in theory is good, but the problem was they were using a screwdriver with a magnetic bit at the end, so they were getting a false reading on which side. So I just encourage, make sure you use something that's non-metallic but non-magnetic when checking. And also right now, what you have on the screen, the use of magnetic viewing paper or magnetic viewing film is super useful. It uses a ferro fluid, which is trapped between the two sides of the card, and that actually will align and show you, give you a visual representation of what the magnetic poles are doing, and also let you count them and let you see if there's any damaged ones. Like right now in the image you have on screen, the left side is a good magnetic encoder. The right side is a damaged magnetic encoder. You can see where the poles are actually fused together, and that could be caused from either heat or a hard impact.
And when the sensor's picking that up, and if you looked at it as a waveform on a oscilloscope, basically that would look like the bearing had basically stopped for a little tiny bit of time.
Yep, yep. It loses its position for just a moment, but that's all it takes to have a ABS issue.
We've got the bearing in the right side. It's facing, the encoder ring's facing the ABS sensor. And is there any issues with pressing that bearing in as far as making sure, will it stop when it reaches the proper air gap for the sensor itself, or is there something a technician needs to do to make sure they've got the air gap correct?
Well, actually, so when the wheel speed sensor is bolted into the knuckle, that's a set depth, so it's a non-adjustable depth. So this is where the air gap is set, both on the depth of the pressing of the bearing into the knuckle, and also when you do the final torque of the axle nut, that's going to set the final air gap. Because as you tighten it all down, the bearing and the flange are kind of getting sandwiched between the CV, the outer CV joint, and the nut, and that's what's going to set the factory preset on the air gap. So not torquing it properly can cause a problem. Having any kind of corrosion between the wheel speed sensor and the knuckle, which sometimes happen. In fact, there's several TSBs that are out there discussing that, which causes it to swell and pull away from the knuckle, which increases the air gap, which can cause some false modulation and possibly some ABS codes to be set. But basically, it's a non-adjustable air gap, which is set by installation and torquing of the axle nut.
Thank you, Matt. Which kind of brings us to our next step, the flange itself. This is another precision fit part of the entire process. And we brought this up before about measuring the depth, looking for corrosion on the axle itself to make sure that you're setting the right depth. And the other key, this is probably the most frequent time that the technician will actually damage the wheel bearing, because they'll either make contact with the seal itself, either with the tool or the flange itself, and damage some of the wheel bearings. Because at this point, there's no preload on the bearing, so it's able to move. So it's key that you be very cautious at this point of the repair, that you're not making contact with anything else except the inner part of the race. Matt, I know that there's a lot of tricks of the trade out there. You know, I've heard the freezer, I've heard dry ice. Do they work?
I've had some success using those, tricks, if you will, but more on the general bearings, the tapered bearings. When it comes to the cartridge style bearings, I've never really had a situation where it's been that bad that I've needed to do that. I'm assuming that it would. The problem is if you've got a deep freeze in your shop and you can throw the bearing in there and freeze it so it'll actually shrink a little bit. By the time you get it out of the freezer and over to the press and handled and set up, and the press, set up the press down, it's warmed up. So in those situations, it may work for you, but again, in my experience, it hasn't really been necessary for these Gen 1 cartridge styles. But in a pinch, it does work, and if you can move fast enough, or you've got a little dry ice or liquid nitrogen that you could be spraying on there, it's almost like you can't apply too much cold, but if you're going to you never want to heat up a bearing because you can heat it up, but you don't want it to go over, I think it's, Mark might be able to answer, I think it's like 200 degrees, because that's when you start affecting the grease and the seal that's in the assembly. So they're not designed to go over a certain temperature range. So
yeah, 130 degrees C.
Yeah, so unless you're really comfortable doing it, you know what you're doing, you modulate the temperatures right, maybe it's just best to, if you're having trouble pressing a bearing on, I would stop and double check the application, double check the part number, because there are some applications where you'll have an option between, one bearing over the other, because one's for the 4-cylinder and one's for the 6, and maybe they got you the wrong one, and the only difference is a couple of millimeters in the outside diameter of that bearing. So if you're really struggling to get a bearing into the knuckle assembly, I would first stop, measure the one that came out, measure the one that you received from the parts store, make sure that they match. If there's any deviation, plus or minus, 1 millimeter, I'd question it and take a look at it. But generally speaking, it's easier to install a Gen 1 bearing into the knuckle assembly because as you press the old one out, there might be some material transfer. You've cleaned up all the oxidation and corrosion, and you've put some assembly lube in there. So if something's struggling, before you go to the oven or the freezer, just double check the applications, the part numbers, and the actual dimensions of the part in the box, because as we all know, sometimes at the parts store, people pull multiple parts out of boxes and they don't always go back in the same box. So just double check all that.
Great advice. Just to finish up the whole flange discussion, make sure that after you've removed the tool, just inspect the seals to make sure they're properly seated inside the outer race of the bearing and there was no damage. Which sort of brings us to our next step, the axle nut and torquing it down. This is probably the most critical procedure because it holds the whole thing together. Make sure you're following the manufacturer specifications when doing this and their procedures. Make sure that the threads are clean, there's no corrosion. You know, they advise against having oil on the threads themselves and also the nut because this can change the amount of torque being applied to it. And just remember, you're setting the load path of the bearings. So we're talking about the ball bearings and the races and how they interact together. And if you get this wrong or if you take a guess, well, that bearing is not going to last very long. That sort of concludes the technical part of the presentation. But you've probably seen through this whole presentation, it's a very precise job. I mean, it's not complex of a part as a hub unit, but inside of there, you're dealing with very exact dimensions and fit, and you're dealing with the electronics and safety systems of the vehicle with the encoder ring and the ABS system. And just make sure that you're using a high-quality part for the wheel bearing and making sure that you're not taking a chance, because not only are you taking a chance with the customer, you're also taking a chance with your pocketbook and your wallet, because if the job comes back, well, you're going to have to be working for free to do that, to put in a new wheel bearing. And another thing I'd like to identify as resources, and maybe Matt and Mark can help me out with this, but the website to go to is bcabearings.com. They have great articles and posts on bearing repair and bearing applications. They also have some great videos. I'm in a few of them. And also they have great tech tip bulletins that are downloadable as PDFs. Any other resources that you can add, guys?
Yeah, no, well, I think Andrew covered it pretty well. The website has a lot, and obviously we have a tech support line that we can be reached out to at any point and help with any issues that arise in the field.
Yep, I would agree. When installing our product, I mean, you're more than welcome to give us a call, and we'll either help you with installation, removal, any torque specs that you may not find available to you, and we'll do whatever we can to help you.
Great, and that number, correct me if I'm right here, for technical support is 1-800-686-8670. Great job, guys. You even brought up some points that I didn't even know myself. So now let's answer some of our audience questions. So for our first question, we have a question from Randy. What would you use for a lubricant on a bore? I was told not to. What reason shouldn't you use a lubricant?
Well, I can jump in here since I kind of started this discussion. I think that what the confusion might be is sometimes you're told not to use a lubricant on threads. And sometimes people think that that means in the whole assembly. But anything that's metal to metal other than threads, it is okay to use a lubricant, not unlike doing a brake job. When you've got any metal to metal contacts, you always want to put a little bit of lubricant there so that the parts move a little bit easier. But the only thing that I've ever been told and or teach is do not use a lubricant on threads. Everything else is pretty much fair game as long as the lubricant is compliant to the materials that are being used, such as the petroleum distillate-based lubricants on anything that's going to be touching rubber.
Great. Here's another great question. This one's actually application specific. This is a Toyota Avalon. Doesn't give a year here. This one comes from Russell. intermittent ABS failure, possibly misinstalled wheel bearing, or could it be an issue with the air gap? I can take a stab at this one. Yes, typically what I've seen is sometimes the driver will hit a bump or go around a corner a certain way, a little bit harder than normal, and that will change the air gap to the point where it will set an ABS code. And it's just making sure if Russell could give us a code, that'd be great, and maybe we could solve this problem for you. Any thoughts here, Matt or Mark?
Yeah, and another big one is also make sure there's no real debris accumulated on the magnetic encoder, or there's nothing, no road debris in front of the sensor. Just to kind of just inspect the cleanliness of the area is really important.
I just want to jump in.
And go. What
I've seen at least a half a dozen times myself was when you'd get an intermittent air gap sensor code or false modulation. A lot of times I will just pull the sensor out of the housing, out of the knuckle, clean the mating surfaces, reinstall it, and then that usually takes care of that problem, because on these styles, unless you've got movement, such as a worn wheel bearing, or it was installed improperly with the wrong air gap because any of the processes that we talked about weren't followed, including improper axle nut torque, it's a preset air gap, and it's non-adjustable. So something is causing it either to be too close or too far apart. And on these, it's either one or the other. It's either going to be corrosion, or as Mark said, any kind of debris that's going to interfere with the communication between the sensor and the encoder, and or a worn bearing.
Another good question here. This one's kind of maybe tough to answer because they don't typically have gauges on some of the presses, but what's the maximum amount of pressure that should be used with the hydraulic press?
Well, there is no set pressures by application or anything like that. It's just, if you've got a 2-ton press, you don't want to go over 2 tons, but you should never hit 2 tons. I guess I've never watched the gauge myself on every time I've done these. I mean, as you're pumping and you'll see the thing start moving, or you won't, and then after 4 or 5 pumps you get a little nervous and you look at the gauge, and then you stop and you re-clean it up, realign it. But there is no rule of thumb that I know of or that I've used, except don't exceed what the press is rated for. And if you get up to that point, you better stop and take a closer look at what's going on.
Okay. Huh. Yeah, I get very scared around presses if you start getting the pressure too high. That's my limit. But we have a great question here. Why do some bearings have metal on the sides and not just a rubber seal? Is the metal a shield? Is it there to provide additional protection to the bearing or the grease unit from heat? And also, follow-up question, this one, do some bearings run hotter than others?
Hey, Andrew, this is Mark. I'll take that one. So yeah, the metal shield is exactly that. It's a metal shield to protect the bearing from road debris, and also from shield it from heat. Typically, you see those metal shields in an application that will maybe generate higher temperatures. So it's just to protect the seal and give it more longevity when it's exposed to a higher temp type application. And especially when you're doing the application, we're using tapered rollers instead of the ball bearings. Those tend to generate quite a bit more heat than a roller bearing design.
Which, wow, this is another question that's right up in the same vein. It says, can other factors such as worn, loose, damaged parts in the brakes or suspension or even the drivetrain cause a bearing to fail prematurely? And what should be done to remedy the condition? I guess he's talking about like CB joints, motor mounts, I guess just high heat applications.
Yeah, I mean, it's kind of a loaded question. There's a lot of things that can affect the life of the bearing and cause premature failure. I would say, in my experience, probably the number one thing to watch out for is any type of alignment issue. That's something that needs to be addressed like right then and there, because if there's any type of issue with alignment, you're essentially introducing forces into the wheel bearing in a way that it's not designed to handle, like a maintained load generated from poor alignment. Yeah, That's a big question. There's just a lot of things that can affect it. But alignment, in my experience, has been the most common thing that causes a bearing to fail, and then a new bearing is replaced, but the alignment issue wasn't corrected, so results in another premature bearing failure.
In my experience too, that yes, if you've got a bad strut, if you've got a tire out of alignment, anything that's going to cause that wheel end to oscillate more than it was designed to, that's going to increase the loads that it's seeing. So the radial loads or the up and down loads that it's seeing are going to be magnified. So if you've got a tire that's out of balance, you've got a bad strut that lets that wheel hop a lot more than it's supposed to, maybe seeing 10 up and down movements as opposed to 1 or 2. Yeah, worn suspension parts and steering components can cause undue wear and tear on the bearing assembly. So I just remember in one case just recently on the tech line, we were getting a call from someone that had installed, two bearings on the right front, left front, and the right front kept failing, and they kept saying it was our bearing that was failing. It's our bearing that's failing. So after 2 or 3 warranty claims, we gave him a call. We talked him through it. We found out that the caliper was dragging on the right front, causing excessive heat, which was destroying the grease in the bearing and causing premature failure. So even brakes hanging up and causing excessive heat can cause premature failure in a bearing assembly.
Well, we have time for one last question. I think this was asked by multiple people. Can brake dust or the iron filings that come off the rotor, can those make their way onto the magnetic encoder ring?
Yeah, absolutely. That can definitely cause an issue with the signal and creating interference with the signal.
Yeah, especially when you get a vehicle in that had a metal-on-metal brake condition and it's just shredding up iron filings all over that knuckle assembly. It's always a good idea not only to replace the brakes and clean everything up, but maybe take a look behind at the encoder and see if you can give it a little blast with some compressed air just to clear the path of those filings away from the encoder and the sensor.
Well, it looks like we're at the end of our time for today. Thank you for attending this webinar. This has been great. I'd like to thank BCA for sponsoring this webinar, and I'd also like to thank Matt Gorski and Mark Tarrant for answering all your questions. I'm Andrew Markell. Thank you very much.